Everyone, and welcome to our next lesson, our last lesson of Unit 2, Part 1, talking about composition of transformations. Today's notes are on a supplemental note sheet you should have gotten in class or printed off of Google Classroom. Now, reminder, a couple of things here. We have rigid motions, and those are our transformations that have the same size and the same shape. No matter what kind of transformation we are doing to it, they will stay the same. Dilations are the only type that we haven't really focused on a lot, but these are not rigid motions because what they don't do is they do not preserve the same shape and the size of our figures, right? They expand the size of our sides or they condense them down. The ones that we have talked about that do work are the translations, reflections, and of course, the rotations. Now, sometimes we are going to combine more than one of these. When we combine our transformations, that is called a composition, and that's when we perform at least two of our transformations, okay? As we've been talking about with just performing one transformation, we start each time with the pre-image. I'm going to call that point P in this example. And after we complete the first transformation, we call that the intermediate image. Okay, so it's kind of like your middle image, right? The intermediate one, and that's R prime, or in this case, P prime for my example, P. After the second transformation, we call this our final image. And in this case, we use two apostrophes. We call that double prime to show them the second one has occurred. Now, as we've talked about before, if we are combining rigid transformations, multiple ones, that also means that our overall shape is still going to be a rigid motion. So if we look at this next example and we say, okay, we are doing a 90-degree clockwise rotation and then a translation, will we have any change to the shape of our figure, in this case, these triangles? The answer here is no. Okay, we're not going to have any change. And why? So are these triangles congruent? The answer there then is yes, because the rotation and the reflection are rigid motions, so they will not change the size. Okay, so these will be congruent to each other, the original pre-image and then our final image as well. Now in the next example, we have a reflection first of a segment and then we dilate it. Would these segments be congruent to each other? Well, the answer there is no. The dilation will change the size of our figure. Now, that being said, again, we can actually use that with legitimate numbers as well. For instance, on this one, we have an initial segment that has a length of 6.3. We're going to rotate it 90 degrees clockwise, and then we're going to translate it. Well, no matter what we're doing to it, if those are rigid transformations like a rotation and a translation are, our figure is going to maintain the exact same size and still be 6.3 units long. Now, sometimes they are going to ask you to visually look at some of these things. So the first one is asking us to focus on arrow A in the picture. And they want us to rotate this 90 degrees counterclockwise. So reminder, we have our clock. Counterclockwise is going the opposite direction. So here, right, that's our counter. So we would be shifting it 90 degrees that direction. And then we are going to translate it 4 units to the right. So we're going to shift it over 4. Well, our arrow, if we take this and turn it, is going to end up turning to be to the left, right? If this is going down and our arrow would point this way. And then as we shift it over, it turns into arrow D on that one. Now, our next example then is asking us to start with arrow C on this one. And what ends up happening with arrow C then is we take that and we're going to translate it 8 units up to start. So it's going to look like arrow B. And then if we rotate it 90 degrees counterclockwise, again, here's our counterclockwise, arrow B will face upwards and look like arrow A. Last but not least, if we take our arrow A again, so we're going to focus back on arrow A, and this time if we go 90 degrees clockwise, so this one is clockwise, that means we'd be rotating to the right. So it'd look like arrow B-ish. And then if we go 2 units to the right, well, here would be the initial just rotation. But then if we shift our arrow to the right 2 units, it officially will look like arrow B. So that's looking at some figures moving around after our composition. Now, we also need to be able to physically plot these points. So this first example tells us we have a pre-image point A that is located at 2, 1. So I'm going to start by graphing that on my picture if it isn't already. Now, the first thing they want us to do is take this and translate it right 2 units and down 5 units. So I'm going to take this point, I'm going to move it to the right 1, 2, down 1, 2, 3, 4, 5. And this again gets labeled as a prime, our first transformation. And that's located at 4, -4. Now I'm going to use a different color to do the next transformation. We're going to take that newly reflected point, or excuse me, translated point and reflect it over the x-axis. So again, we're using the green point and we're reflecting that, not our original pre-image point. We're using the intermediate image. So 1, 2, 3, 4 units away from the x-axis. We now need to go 4 units the other direction so that we get our A double prime located there. Now that final image then is located at 4, 4. So we want to make sure that we do 2 things here, that you not only graph it, but you also fill out this chart. All right, now we need to be able to do that process not only with one singular point, but also with some other points combined, right? This time we have a triangle that we're trying to start translating as well as reflecting. So we're going to start this time with a reflection over the x-axis of our original triangle. So we have 2 points, T, U, and V. T starts 1, 2, 3, 4 units from our x-axis. So we're going to reflect it then 4 units the other way to become T prime. U is 2 units below, so now it's 2 units above. So there's U prime. And then V is 5 units below, so it will move 5 units above the x-axis. So here is our image of TUV. So T is at 0, +4. U is at 3, +2. And V is at 4, +5. Excuse me, V prime. And that's T prime, U prime, and V prime. Now our final image then, again, I'm going to change colors, is going to require us to then translate each of those prime points to their new location. So we're going to take T prime, we're going to move it to the left, 1, 2, 3, 4, 5, and down 3. This is now T double prime. U is going 1, 2, 3, 4, 5 to the left and down 3. So there's U double prime. And then last but not least, we have V double prime moving 5 to the left and down 3. So we have V double prime. So our points then, we are at, for T double prime at -5, 1. Our U went to the left 2 and down 1 from the origin. And then last but not least, V is to the left 1 and up 2 to get V double prime. We will work more with these compositions in class. Thanks for watching.